Hi, good afternoon. This is a video to refresh your memory on how to solve an algebraic equation. And in order to talk about this a little bit more concretely, we're going to review how to simplify an expression briefly. So we'll do one example on how to simplify an expression using PEMDAS. Please excuse my dear Aunt Sally. So the order in which you simplify an expression is you do the parentheses first from left to right, then you do exponents, all the exponents from left to right, then you do all multiplication and division from left to right, and you do not show preference. So if the division comes first, you do the division first. If the multiplication comes first, you do the multiplication first, but you do both of them from left to right as they appear. And last but not least, you do adding and subtracting from left to right, all right? To clarify, parentheses should really include all grouping symbols, so not just parentheses, but also any brackets, also any invisible parentheses. So for example, whenever you see a fraction bar, they might not write the parentheses on the top and the bottom, but they do exist there, all right? So anytime you see a parentheses, a bracket, or a fraction bar, you should know that there's invisible parentheses or grouping symbols, and those would go first. All right, so we're going to simplify this. So the first step is going to be parentheses. So we're going to do parentheses or grouping symbols first. Well, this fraction bar means that there are invisible parentheses over right here. So from the very get-go, I'm going to do the 3 minus 1 first, so that's going to be 2, and 16 minus 6 is going to be 10. Another grouping symbol right here, because that's a parentheses, so 15 minus 10 is 5. And then there are no more grouping symbols, so we'll leave that view right there, and the parentheses are done. The next thing I'm going to do is the exponents. So there's an exponent right there, so 5 squared is going to be 25, so I'll do that next. And I'm just copying down the rest of the equation. So the exponents are done. Next is multiplication or division from left to right. So 2 over 10 is like a division sign, because a fraction is like a division sign. So 2 divided by 10, I'll do that first. That's 1/5. Minus 25 plus, so now we've got a multiplication, so we're going to have to do that. So 5 times 6 is 30. And then we're going to divide by 2 next. In whatever order the division and the multiplication appears, we do them. So 30 divided by 2 is 15. All right, so we're done with that. And now we're going to do whatever's left, the adding and the subtracting. You do have to do it from left to right, though. So it is 1/5 minus 25 first. You cannot do 25 plus 15 first, or you will get a different and wrong answer. So 1/5 minus 24 is negative 24 and 4/5. You can do it with a calculator, or you can just remember that 1/5 minus 25 is the same thing as 25 minus a fifth, but with a negative sign. So that would be 24 and 4/5. Plus the 15. So you would do that, and I believe it's negative 9 and 4/5, but you can check that on your calculator. All right, so that's a review of order of operations using PEMDAS. Now, solving an algebraic equation uses a very similar order, but except backwards. So instead of PEMDAS, you're going to solve using the order of SADMEP. A good way to think about that, or a funny way to think about that, is that you can think of an X as a gift that your teacher is giving to you, because the teacher knows what it is, but you don't, okay? So the teacher knows what the value of X is because she or he has made up the problem. And so she makes up this problem and she knows what it is, and she wraps it up in a lot of fancy stuff, and then she's going to make it equal an answer, and you're going to have to find out what that gift is. Well, let's say that when I have a gift, I put it in a box first. So first step to wrap a gift is I'm going to put it in a box. The second thing to hiding that gift and wrapping it is going to be to use gift wrap around the box. And then the third thing I'm going to do is put a bow around that gift wrap. Well, when you unwrap that gift, which one, excuse me, not a box, a bow. What are you going to take off first? The box, the gift wrap, or the bow? Well, you can't take off the box first because it's wrapped around with gift wrap, so it's hidden there. So you're going to have to take the bow off first. So the order in which you're going to solve is backwards. You have to take the bow off first, then you have to take off the gift wrap, then you have to take off the box. And so when you're unwrapping a gift, you have to do it backwards. Likewise, when you're solving an equation, you have to do it in the reverse order using SADMEP instead of the order that you're used to, okay? All right, so we're going to go ahead and solve an equation and see what that looks like using SADMEP, all right? All right, before we even get to SADMEP, we do want to do a few things to simplify this equation. So if you have any like terms, you're going to want to combine them. So 2.3x plus 2.5x, we're going to combine that. So that's going to be 4.8x plus 1.2 equals, and I'm just going to copy the other side. The next thing after you simplify each side as much as you can by combining like terms is you don't want x's on both sides of the equation. So anytime there's a variable on both sides of the equation, you're going to have to get rid of one of them. So you get rid of it by adding or subtracting it, and I'm going to get rid of this one. So if it's a minus 4.3x, we're going to now start with the inverse operations. To get rid of something, you do the opposite. So if it's a minus 4.3x, you're going to add 4.3x to both sides. Again, this should be a refresher, so you should remember this from doing this a while back. So 9.1x is going to be on this side plus 1.2 equals 9.2. All right. Now that we've moved all the variables to one side, so there is no x's on both sides, now we can use that order of operations I was talking about. So I'm going to write that on the side here. And it was PEMDAS backwards or SADMEP. So that's going to help because when I'm solving for x, I'm isolating it. So I'm isolating the x. That means I don't want this whole thing equals 9.2. I don't want 9.1x plus 1.2 equals. That's too much stuff going on there. I just want x equals. I want to know what x equals. So that means I need to get rid of this 9.1 and I need to get rid of this 1.2. So I need to get rid of both of those things so I can get just x isolated by itself. Well, which one do I have to do first? And there is an order. So you do have to do it in a particular order. And that's where SADMEP comes in. You always do it in the opposite, in the order of, the opposite of PEMDAS, so in the order of SADMEP. So you're going to do anything that's subtracted or added, you have to get rid of that first. So that's this, okay? So if it's plus 1.2, I'm going to get rid of it. And you, again, inverse operations, to get rid of a plus 1.2, I'm going to subtract it. And whatever you do to one side of an equation, remember, you have to do the same thing to the other side to keep it balanced. And so that will get rid of that. And on the side, we'll get left with 8. And on the side, we'll get 9.1x. All right, so we've done any subtraction and addition. So the next thing is going to be to get rid of any multiplication and division. So this is a 9.1 times x. So we're going to get rid of the multiplication by doing the opposite, which is divided by 9.1. So we're going to get x equals 8 divided by 9.1. And if you just multiply the top and the bottom by 10, which you can do because 10 over 10 is 1. So if you multiply by 10 over 10, you're really multiplying by 1. If you multiply by 1, you're not changing any values. So you're allowed to do that. So that's going to be 80 over 9.1. So that will be your answer as a fraction. Now the worksheet, if you got the worksheet, says to round it to the nearest tenth. So if you do 80 divided by 9.91, you should get 0.88, I believe, to the nearest, to the nearest hundredth place. So to the second decimal place, that should be about 0.88. Let's do one more example to refresh your memory. It's also a good idea, if that was a little rusty, to just go back and redo that example, even to kind of shut off the video and see if you can do it again, but by yourself without watching the video. But if you're ready for a new example, here is another one. All right, so again, the first thing I'm going to want to do is simplify this equation before I even do inverse operations and do the SADMEP method. So I have variables on both sides, and I don't want that, but also I have a fraction on the side that's making this look harder than it is. So to get rid of a fraction, remember that you can multiply by the common denominator. In this case, there's only one denominator, so then you can just multiply by that denominator. And you just have to make sure to do everything. So you have to multiply the entire equation by 9.2 on both sides to keep it balanced, okay? So I'm going to rewrite this equation just to show you how it gets distributed. So I'm rewriting the original equation, but with a lot of space. And then every term gets multiplied by that 9.2. So this fraction counts as one term. Anything that's added or subtracted counts as one term, so that x is also its own term, so that has to be multiplied by 9.2. and then the plus 0.2 is the last term. So that also has to get multiplied by 9.2. When you multiply a fraction, you can cancel out the denominator, so you're left with a nice, easy non-fraction on the left. On the right, you're left with 9.2x, and multiplying that, plus 9.2 times 0.2. You can use a calculator for that. That's going to be 1.84 with a plus sign in between. All right, again, we can't have variables on both sides, so you might want to pause the video and see if you can solve it from here on your own, because we did this in the last problem. But we don't want that variable on both sides, so we're going to want to get rid of them. There's an invisible 1x here, so to get rid of the plus 1x, I'm going to do the opposite, which is subtract 1x from both sides. That cancels out. Now we're left with an equation that has only one variable, and is simplified. So now we can start using SADMEP to solve it. And I'm just going to rewrite it so that the x is on the left side, so it's a little more normal looking. I'm going to write SADMEP on the side. We're going to do subtraction and addition first. So I'm trying to get what x equals, remember? So I don't want times 8.2, and I don't want plus 1.84 there. I want to get rid of those things and get x isolated. So to do that, I'm going to want to get rid of the plus 1.84 by subtracting it on both sides. Okay. So I get rid of the plus 1.84 first. That's adding and subtracting. By subtracting it on both sides, I get 8.2x on the side. And on the side, 1.84 divided by 0.8 minus 1.84, excuse me, should be negative 1.0. And then I want to do get rid of anything that's multiplied or divided to the x, which is the times 8.2. So I'm going to divide both sides by 8.2. And again, to get rid of the decimal, I can just multiply by 100 over 100, which is just 1. So it doesn't change the value, it just cleans it up. So it's negative 104 over 820. It's not reduced, but that is going to be the answer. Now, again, the worksheet says to round it off. So if you do that in your calculator, you can round it to the nearest hundredth, which is going to be x is equal to negative roughly 0.13. Do one more example with you. I'm going to skip one on the paper. Do this one because it's different. All right, so for this example, I don't have a variable on both sides, so I don't have to worry about that this time. I can simplify it if I want, and that is completely legitimate, and that's a way you can do it. Or I can do SADMEP right away. So I can solve by doing inverse operations, whichever one you prefer. If I do SADMEP right away on this one, I would do subtraction or get rid of subtraction or addition first. So anything that's added or subtracted to the x. All right, so remember that I'm trying to get x equals. So that means I need to get rid of the plus 0.4 and I need to get rid of the times 0.8. I don't want those two things. The thing that I want to specify here, though, is that this does not go first. Think about why that is. Your subtraction or addition is supposed to go first. That's what you're supposed to get rid of first. But here, that is not what's going to happen. You're going to actually get rid of the 3.8 first. You want the answer. It's because the plus 0.4 is actually inside the parentheses. So all these things that come before the parentheses, it's it only works if it's outside of a parentheses. So you do get rid of subtraction and addition that's outside of a parentheses. Then multiplication and division that's outside of a parentheses. Then exponents that are outside of a parentheses. And last is anything that's inside of a parentheses. That goes last. So because this plus 0.4 is inside of parentheses, it does not count as this. The times 3.8 is outside the parentheses. So that's what actually counts as the first thing in this problem to do. So I have to get rid of the times 3.8 by dividing by 3.8. So you're going to do 1.14 divided by 3.8. And I'm getting 0.3. Then the next thing is exponents, but there are none. And then the last thing is parentheses. And this x plus 0.4 was in parentheses, so now I can go in the parentheses and get rid of the minus 0.1. So x is going to equal negative 0.1. Hopefully that was helpful to refreshing your memory.